This time, we are tasked to determine the points of discontinuity for a given function here, f of z, be identified as a rational function with complex numbers 2z minus 3 all over z squared plus 2z plus 2. Again, we have here the given function f of z is a rational function with complex numbers 2z minus 3 over z squared plus 2z plus 2. Let me rewrite this for better illustration of our z. Alright. Now, we are asked here about the points of discontinuity. In short, we are asked to give or provide all. And take note, we are only focused on the points of discontinuity. We are not asked about whether this is continuous at a certain point. We will have, we had examples as similar to that, but this time focusing only on the points of discontinuity. Now, this is a rational function. We know that the rational function is only undefined, thereby stating the function to be discontinuous if the denominator is equal to 0. So we're going to solve for that. We have here z squared plus 2z plus 2 is equal to 0. Okay? Because this should not be equal to 0 for it to be continuous. But since the question is points of discontinuity, let's assume it to be equal to 0 and solve for the given quadratic function now using the denominator. Now, of course, this is a quadratic function or quadratic expression or equation. We can actually use all the methods. You can even use the quadratic formula, or in this case, allow me to use here computing the square method. Okay, so allow me to have z squared plus 2z, or breaking it 1 plus 1, so that I could actually place the 1 on the other side. You have your z squared plus 2z plus 1 is equal to negative 1. Computing the square means moving it here, so you can also have z squared plus 2z is equal to negative 2, but you'll be adding here 1 to make this a quadratic trinomial, so adding 1 here would still result to negative 1, a similar thing. Okay, so the point here is we have already come up with a quadratic trinomial, which is a perfect square trinomial on this side, and then this time we can have here the square of a certain binomial z plus 1 equal to negative 1. Now, to continue with this, of course, solving for z, we can take the square root of both sides, making this side as just z plus 1, but the other side will be equal to the positive and negative of square root of negative 1. Take note, we are now on complex numbers, hence we accept these forms now. But of course, that's just equivalent to, okay, z plus 1 is equal to plus minus of your I, since square root of negative 1 is equal to I. Okay, so with this now, z is equal to negative 1, as we move that here, plus minus I. So the points of discontinuity of the given function here, or the given function is discontinuous when we have here z equal to negative 1 plus I, I'm using or because any of them could make it discontinuous, but since the question is finding the points of discontinuity, so both of them must appear. So you have here negative 1 minus I. If we're going to substitute this on the given function here, it might not affect the numerator, but surely the denominator would be equal to 0, making the entire function discontinuous. So again, this is the correct answer. Of course, you could use as well the quadratic formula. Okay, this would be your A, B, and C. So your A is 1, B is 2, and C is 2, without needing to come up with another term for making one side become a perfect square trinomial. You can simply use the quadratic formula. Instead of x, it's just z, negative b plus minus square root of b squared minus 4ac over 2a, and surely you will get the same values here. I'm gonna let you do that by yourself, but this time we are now assured of that these are the correct answers for the points of discontinuity, or these are the points or values of z where our given function would be discontinuous. Thank you very much for watching.